In this video, I'm going to go through the 2017 Engineering Studies HSC exam. Starting with multiple choice, question 1, which is the primary responsibility of an engineer? Manage successful deliveries of engineering projects. C. So, local media, typically that's not an engineering role, typically that's a communications officer, and they're usually someone with an arts degree. Engineering research, it is definitely an engineer could be doing that. Someone with a Bachelor of Engineering could be working at a university, but it's not typically what we think of as a working engineer. Now, WHS requirements are important, but that is part of C. Yeah? So that's why we're not including that as the answer. Okay. Question 2, which is a symbol for a diode? D. Okay, so the other ones, this would be a resistor. This is a capacitor, I'm going with. This is a battery, and this is a diode. So, quick questions we could, so diodes are made of 2 layers of semiconductors. That means doped silicon. They only allow flow of electricity through one way. If you have 3 layers of semiconductors, doped silicon, we get a transistor. Transistors have 2 functions. Transistors can either be amplifiers or switches. Typically switches, but good to know the other one. LEDs can also, LEDs are light emitting diodes. How you draw that is you draw 2 arrows coming off the diode or a little lambda symbol, the Greek letter lambda. I'm not going to look that up because it's not the question. Okay, we've got a mass of M. It's at theta degrees from the horizontal. What expression is used to calculate the normal reaction N? Without me getting out the texters and drawing on the board, yeah, if we draw the triangle, so effectively we've got a triangle. If you can watch the mouse that I'm going to draw here, so we've got the weight, which is always vertical, and is always the hypotenuse, and then we have a triangle like that. So if this is our hypotenuse, we're interested, the normal is the side that is adjacent to the hypotenuse. So we're going to use cos, because it's the one adjacent to the hypotenuse. Well, they're both adjacent to the hypotenuse, but relative to our theta, it's the one that's adjacent. Okay. Now, question 4. This is a bulk question. Now, there were several questions in this exam that were disputed. No, sorry, this is not one of them, but I will talk about not disputed, the next question, where there were a lot of comments made about the questions and their suitability, but that one we'll get to in a second. Okay, it's a tolerance of 0.5 millimeters, so that means that it's C, between those ranges. Yeah, that's what it means when it's plus or minus. Now the problem is, I typically don't teach this because it's not something we cover in the book. It's not something that the syllabus is very vague, and so they do talk about Australian standards, but the Australian standards is a 200-page document, and we really only focus on a few pages of those. So yeah, I could see that this is a question that could be disputed. Okay, question 5. Now it says copyright is restricted. Now I have the picture. I collected an example of the test at the end of the test, but what it's a picture of. It's a picture of grains. Now, I get a picture. Okay, the picture looks something like this. For all intents and purposes, it's probably something like this. Now, the question is, does that look equiaxed or does that look stretched? Do they look like they're roughly the same size, or do they look like they're noticeably squashed? Noticeably random. So if we look at this chunk here, does that look like it's a circle, or does that look like it's an oval? Okay.
Yeah.
So same thing here. Okay, what about this one? Yeah, so we call that equiax. Equiax doesn't mean that they're circular. Yeah, it just means that they're roughly the same height. That there's no the x direction doesn't look like it's being favored compared to the y direction. Just think of it that way. Yeah, if there's an obvious direction where they're much thinner in that direction, in that axis, that means they're elongated, which means that they are deformed, right? Or, now stressed is, I guess, a word that they've just added in there. So dendritic, what does dendritic mean? Is dendritic... Well, it means little trees, but so if we talk about grain growth, one second. Okay, this stuff here, that's called dendrites. So we start off with nucleation points. The nucleation points, the little dots, grow into little trees or dendrites. And then eventually when they start to meet, we form grain boundaries. So when we draw a picture, so these are equiax grain boundaries. because even though they're not circles or squares, they're not favoring a direction. They're not favoring the x-axis or the y-axis. Yeah? Okay. Back to the exam. Okay, so we have an aerofoil. Which condition needs to be achieved to have lift occur? The pressure at 1 has to be low pressure, so it's sucking like a vacuum cleaner, and the pressure at 2 has to be high pressure. It's like pushing like a compressor. Yeah, that pushes the wing up. So we need lower pressure above, so lower means that pressure 1 is less than, so A. Okay, so my router has both a 24 gigahertz and a 5 gigahertz. Which statement is correct? So which one should I be using is a question my wife asks me all the time. Okay, 5 gigahertz, I won't read them out. Now, attenuation isn't a word that I use a lot. What we talk about is, we talk about AM radio reaches a longer distance. Yes, that means it has less attenuation. FM radio has higher attenuation, means it reaches a shorter audience. So, in this case, if something has a lower attenuation, it means it goes further. Now, do we think high frequency waves go further, or high frequency don't go as far? Yeah, so the high frequency gets caught by the atmosphere. It has higher attenuation. So high frequency, high attenuation. Now, does high frequency have high bandwidth or low bandwidth? So that makes the answer B. High attenuation, high bandwidth. How much information? So the more waves we have per second, the more information, the more Morse code we can send.
So high frequency and high bandwidth.
High frequency. So in the case of my router at home, we have two, and so they're called Batcave and Duck and Chicken. My children named them each. So I can't remember which one's which is the problem. So the 5G is better if you're sitting close to the router because you're going to get faster speeds. The other one has good reach. Yeah, so it reaches the bedrooms. That's right. So, okay. Now, which correctly identifies the properties of cold worked metal? Okay, so when we cold work a metal, how cold work metal, this is me not reading the question, that's really important. Now, it's different when I'm recording a video compared to if you guys are reading, but do make sure you read all the words. I've heard people say underlining is key. Yeah, so cold worked metal are changed to annealing. So annealing, what do we do? Does hardness go up or down if we anneal?
Hardness goes down, I think.
Yeah, okay. And so ductility increases, yeah, good. And the internal stresses decrease. Okay, when we anneal.
No stress.
So I do talk about, so these days I now talk a lot more about the three is fire, air, and water. So the fire one, so Hawaii, it's the volcanoes, the fire island, right? But yes, they're bigger, they're quite relaxed, they're slow. Yeah, so that's what I yeah. Anyway, that's the comment I'm going to leave there. Okay, so moving on. This is a good question, I think. It's a tough one because we talk about the syllabus talks about uniformly distributed loads. It talks about point loads. This is what we call a triangular load. So question C is a bit of an oddball. Now in multiple choice questions, they are allowed to have what they're called distractors, incorrect questions that are not part of the syllabus. But I do like the idea of it. But which one shows a uniformly distributed load? A. Yeah, so uniformly distributed, how we represent that is through little semicircles. Yeah, you can represent it through lots of little arrows, but we typically throw it through little semicircles. Okay, Hooke's law. Now I often talk about Hooke's law in discipline, where you give people warnings, incrementally increasing warnings before you lose your cool, before you snap. So Hooke's law is what they discovered before Young discovered the modulus of elasticity. What Hooke figured out was just that the elongation was proportional to load. Eventually Hooke said, hey, if you also know the material properties and the area, you can predict the exact relationship. So that's where his modulus is an advancement on Hooke's law. Okay, so which was the one here?
C.
Okay, force induced on an object by stretching is proportional to its extension. Great. Okay, some aluminium, magnesium, silicon alloys can be altered using the following procedure. What is this called? Solution treating, quenching, reheating. Precipitation hardening. That is exactly right. Now, without going to... Let me see if I pause. We'll see if we can find... Okay, so I made this for Year 11's ferrous metals. I will provide this for you guys if you want it. Now, most of it, I would say, don't worry, right? It's typically only really relevant to year 11, but if you want to have a look at it, you can. Now, precipitation hardening, I have taken the picture from the aluminium one and I've replaced it with my own pictures, right? So, effectively what we get when we precipitation harden, this is for steel, right? Unfortunately, I don't have the picture for the aluminium one on me. But what happens is that well, let's go through back to the question. Let's have a look. So we have solution treating, right? So what that means is that we're going to see these little grains of beta? We're going to get them dissolved. So the solution, so at the moment we have the solute, the part that's not dissolved, and then we're going to have that be completely dissolved by increasing the temperature. So they're called like conditioning. Solution treating is conditioning. Then we quench quickly, and then we reheat, and we age it. And then what that does is that will eventually produce microscopic inclusions. Why do we do this? Why do we do this? We do this so that way we have tiny microscopic disruptions of the lattice, which give us additional hardening. Okay, so precipitation hardening. Precipitation hardening is also the heat treatment that we think of when we talk about aluminium. There are three main classes that are heat treatable. So the 2000 series, which has copper, and the 5 and it's the 6 and the 7. Sorry, so 6 is with magnesium, so Dirty Harry, and 7 is like 7-zip, if that helps you, because 7 looks like a Z. Zinc, yeah, zinc because it looks like a Z. Yeah, the correct page is for aluminium is what page? 130. Okay, great. Well, I get it. And yeah, here's the page 130. Okay, back to the exam. Okay, so this is another question that, look, I know that these questions are a thing, that these questions can be in the exam, but I agree with some of the comments on the internet, which is we shouldn't be teaching students to memorize facts that should be looked up on the day. Because, and the biggest thing that irritates me about this is there's two standards. There's structural and non-structural. And ironically, we teach you the non-structural. I would say we should at least be teaching you for the stronger of the two bolts. That would be the conservative practice. The point is that we have to look up what the chart is. So here we have the book, and we can see that for the bolts to the standard that you are being told to use, it's 1.8D. Right, now that is the distance between what we call across the corners, 1.6 across the flats. Now we also need to know the head of a bolt is different to the head of a nut. The depth of a bolt is different to the head of a nut. So let's have a look at our question again and see what it's asking us to do. They're asking for a bolt, right? Are they asking across the flats, or are they asking us between the corners? No, it's a flats. So if we were to draw that, if we were to draw this up, we'd be looking at across flats, yeah? Oh, sorry. No, you're so that's a flat. That's the other two sides. Yes, you're right. It is across the corners. So it should be. So it's got to be one of the 18s. Sorry, I'm not going to edit that because I'm lazy. But okay. So now, which depth is it? Is it 7 or 8? 7 because it's the head of a bolt. It's not a nut. Now, let me just check that it is actually a size 10 bolt. Yeah. Okay. Now, personally, I think that learning that stuff for an exam, I just say do it the day before. What I will also point out is I do have a video on this channel where I've gone into a great detail about all of the things you need to know about bolts and nuts. So that's a video that's available to you. I now need to pause because this is going to be the end of the video. Join us next time on part 2.